Okay, math marbles, we're going to start again by being really intentional and focused. So what you're going to see me do today is to use ratio tables, or honestly, there are other valid strategies you can do, but we're going to try and make larger equivalent ratios. In this case, I'm going to make 3 using a strategy today. But just understand there are others that are valid. I want to make sure that we're writing ratios correctly and keeping order in mind. And we can also use cross products to test for equality or inequality. In other words, we can just use this to make sure that our ratios are equivalent. So let's hit pause before we go right into our practice. Okay, math marbles, we are going to make equivalent ratios as fractions, and these are going to be larger ratios, not smaller. Smaller, we know we can use the greatest common factor to simplify, and we'll have a more simplified rate or ratio, but we're going to make bigger ones for today. And we're going to use this as an example, film A and film B. So just by looking at film A and film B, you can see a quantity of 5 and 7. So what I'm going to do is I'm going to use 2 different strategies. You're going to see me use a table as well as a multiplicative pattern, because remember, our brains are pattern seeking. So let's start by drawing a table. I'm going to change the color here. And what I'm going to do is I'm going to put our 5 7s as our first ratio. Okay, because I'm comparing A to B, 5 to 7. And usually when I start this off with kids, they tend to see like an adding pattern where you're adding 5 and adding 7 and adding another 5 and adding another 7, which is fine. So if that's the way it makes sense to you, we can start off there. So we're going to add 5 A's on top and 7 on the bottom. We're going to be consistent. And we're going to add another 5 A's and another 7 B's. And you'll start to notice on the top that you have a multiplication pattern. So yes, you are repeatedly adding by 5s, or you are multiplying by 5s. So 5, 10, 15, 20, 25, 30, 35. You can do the same thing with B's. 7, 14, 21, 28, 35, 42, and 49. And each of these boxes represents a ratio written in fractional form. So you can see them in there, and you can use this additive pattern to actually do this and skip counting. That's why a lot of kids actually like this. It's just like skip counting. And we can also write this in fractional form, 5 to 7. So we're going to start off with just that. Now, if I wanted B to A, then I would start with the first number for B, which is 7 to 5. Still fractional, it's not improper because I'm just comparing both quantities. So again, just going back a little bit, and I want to make a connection to what we did before. I can take any of these ratios. So let's say I wanted to take 5 7s and 20 28s. And we can use our cross products to compare, or you can look for a multiplication relationship. So just look at it for a second. Do you actually see a multiplication relationship from 5 to 20 that is also true for 7 to 28? Do you see one? Well, you probably noticed that if you multiplied both of these by 4, you would get the second ratio. So that is a multiplicative relationship, where if you multiplied by 4 over 4, you would see the pattern here. You would get that second fraction, that second ratio. Now, why does that happen? Why is that true? Well, math marbles, looking at this 4 over 4, we know that that is the same as 1. And we know that anytime we multiply a number times 1, we get the same number. In other words, in this case, even though they don't look the same, these two are equivalent to each other. They are still proportional. They are still equivalent to one another. We have maintained that relationship. So this is one pattern. Now, if that is hard for you to see, and you don't see a relationship, like you don't see a multiplication one, you can do what we've been doing, which is to do our cross products and multiply in the next and figure out, do they have the same product? So 7 times 20 is 140. And how about 5 times 28? Ooh. I know it's 140, but I actually want to just triple check. So 8 times 5 is 40. 5 times 2 is 10 plus 4. Oh, see, 140. So you do get the same value. They have that same relationship. We've maintained them. They are equivalent to one another. So this is strategy 1, where you can make a table. And with a table, you can make a number of equivalent ratios. And in today's lesson, you're going to need to make 3. So this is a quick way of making 3. Another way you can just make 3 is just to create a multiplicative relationship. So for example, what if I decide I'm going to multiply this by 3 over 3. Some teachers will say, oh, it's a magic number 3. I want to be really, really accurate and call it 3 over 3. That's the true value of this. We're not multiplying by 3 over 1. We're multiplying by 3 over 3. And you would get 15 over 21. And you can see it actually on our table right here, 15 over 21. Or you can say, I want to multiply these by 20 over 20. Okay, you get 100 over 140. So again, as long as you are multiplying by a fraction equal to 1, and you can tell it's equal to 1 if the numerator and denominator are the same, then you will get an equivalent ratio and a larger equivalent ratio. So I'm going to pause here for a second so you can jot this down. You now have 2 strategies. Okay, so let's go to the next page. Again, you have the table strategy, or you can use a multiplicative strategy. So let's look at this next part. And now we're going to use some thinking. We're going to take a lot of what we've learned to talk more about ratios for a second. And let's read the situation carefully. So we have Sammy and Caden. They went fishing. They're using shrimp for bait. Sammy brought 8 more shrimp than Caden. Then they combined their shrimp and they had 32 shrimp together. So this is a lot of information. So let's kind of just picture this out. We know we have Sammy plus Caden, and together they have 32 shrimp. We also know that Sammy has 8 more shrimp than Caden. So how would I represent that? Okay, Sammy has the same amount as whatever Caden has plus 8. Okay, so I'm just going to use this just for some thinking. And our first question is, and this is going to be the toughest one, so I want us to think about this one together. How much shrimp does each boy bring? Okay, so I'm going to start by just I want to just visualize this a little bit more. And I'm going to use this model to help us. Okay, and we know that together they both have 32. They both have 32 shrimp together. And we know that that is the same as if I had Sammy's, and Caden. Added together, they both have 32. This doesn't really give me enough information because I have no idea about Sammy's or Caden's. So I'm going to try arranging it in another way. Okay, so we know that Sammy's is the same as Caden plus 8. So remember, I had split it in half. And I have Caden on one side and I have Sammy on the other. I took Sammy's part away. And I know that Sammy has the same as Caden's plus 8. Okay, this is where it gets helpful. So now looking at this information, check this out, Math Marvel. Look at the jump we're going to make in our thinking here for a second. I'm going to write a number sentence with this. If I take Caden shrimp plus Caden shrimp plus 8, I will get 32. Now, if I took away this 8, if I took this 8 out, how much shrimp do I have? I took this 8 out of the bucket. How much shrimp am I going to have, Math Marbles? Just take away the 8. I'm going to have 24 shrimp. Okay, So that's all I did. I just took away those 8 shrimp. So now I just have what Caden has plus what Caden has makes 24. So now think for a second. A number plus the same number, plus whatever Caden had, plus whatever Caden had, makes 24. So a number plus itself makes 24. 12. 12 plus 12 makes 24. So Caden has 12 shrimp. So I'm going to write that down in my first part. Caden has 12 shrimp. And if Caden has 12 shrimp and I know that Sammy has 8 more, and then I know, well, Sammy has, and this is all I'm doing in my head, I'm doing 12 plus 8, yes, 20 shrimp. There we go. And boom, we've answered the hardest part of this whole problem. This was the toughest one. So pause there, ask your teacher if you have any other questions, or drop it in the chat if you have other, or you can always put in the comments if you have a question on that part. I can always dive in deeper into problems like this. So let's jump into the other ones now. Now we're just going to represent the ratios. In this first part, what is the ratio of Sammy shrimp to Caden shrimp? So all I'm going to do, I want Sammy to Caden. Okay, Sammy has 20. Caden has 12. That's it. Let's go to the next one. I want to express the number of shrimp that Sammy bought as a fraction of the number Caden bought. So again, remember, I'm comparing parts and parts. So now all I want is Sammy to Caden in fractional form. This is still a part to part. So 20 over 12. All right, so I have this one here. Now, I'm not simplifying right now. I just want us to get the idea of what I did. I'm just comparing 20 and 12. If, and you should, put this in simplest form, you would use your greatest common factor. So just like we normally would with math, we would look for the greatest common factor, which in this case is 4. And again, you would use that pattern. 20 divided by 4 is 5. 12 divided by 4 is 3. And just to be accurate, because see, Math Marvels, even me, sometimes I should always be accurate. I should have simplified this one as well to 5 to 3. That I will go and self-correct. All right, so let's look at the last part. The ratio of the number of shrimp Sammy bought to the total number of shrimp. Okay, so I want Sammy's to the total. So I need to know all together how many. All right, so we know Sammy had 20, and we know the total was 32. So that is part to total. And again, I want to learn from my mistakes, so I'm going to simplify that. So what is a common factor? I can divide 20 and 32 by 4. I can divide both of these numbers by 4 again. Which is the same. 20 divided by 4 is 5, and 32 divided by 4 is 8. So 5 to 8. And lastly, what fraction of the total shrimp did Sammy bring? So again, now I'm going to do the fraction, Sammy to total. So this is a part to whole relationship. So I would have 20 to 32, which we know simplifies to 5 to 8. So that's it, Math Marbles. We're going to pause there. So just take a look. All we're doing was putting ratios in fractional form, making sure they were in simplified form. And so not only do you know how to make equivalent ratios that are bigger using either a table or a multiplicative pattern using multiplication, you could also express ratios and simplify them using your greatest common factor. So we're going to pause there for now so you can jot these down into your notes. and get some practice in. We're pulling together lots of different ideas. This is starting to get a little tougher, but we chunk it together. We can do this work. So I will stop here for today, and I will see you in the next lesson, Math Marvels. Take care.